The debate between the semi-automatic 10mm and the classic 357 Magnum has been raging at gun counters for decades. Most people will tell you they are ballistically identical, that a flat-nosed 10mm brings the exact same energy to a target as a traditional revolver cartridge. But those people are looking at standard ammunition catalogs, not real-world defensive performance metrics. When you step off the spreadsheet and onto the pavement, the modern tactical landscape shifts drastically. Today, we are tearing down the numbers, the mechanics, and the terminal ballistics to show you exactly why the 10mm semi-automatic platform completely outclasses the 357 Magnum for modern defensive use. We are not just talking about capacity. We are looking at dynamic recoil mitigation, kinetic energy retention in short barrels, and real-world barrier defeat. Magazine capacities and cylinder crines. Let us talk about the stark reality of cross-sectional real estate. When you strap a traditional wheel gun to your hip-chambered in 357 Magnum, you are looking at a hard physical limit of 6, or maybe 7 rounds if you are running a heavy, wide-cylinder frame. That is a mechanical ceiling dictated by the physical diameter of the cylinder itself. If you want more rounds, the cylinder has to grow wider, making the platform thick, heavy, and incredibly difficult to conceal effectively on a daily basis. The 10mm automatic completely shatters this tactical limitation through the efficiency of a staggered column box magazine. In a standard duty-sized semi-automatic platform, you are looking at 15 rounds in the magazine plus 1 in the chamber. That is 16 total rounds of full-power, hard-hitting capability ready to go without a single reload. Mechanically, this means you have well over 200% more theoretical stopping capability on tap before your gun runs dry. In a high-stress defensive encounter, statistics show that accuracy drops significantly due to adrenaline and rapid target movement. Having 16 rounds instead of 6 does not just give you more chances to neutralize a threat, it completely changes your tactical calculus. You can effectively engage multiple adversaries, lay down suppressive fire if moving to cover, and maintain a massive reserve of ammunition without the immediate, desperate need to execute a complex reload under fire. Spillet times and recoil impulse mitigation. When you are fighting for your life, the clock is not measured in minutes, it is measured in fractions of a second. This is where the mechanical difference between a semi-automatic 10mm and a 357 Magnum revolver becomes a matter of survival. With a traditional 357 Magnum revolver, the entire force of the recoil impulse is transmitted directly back into your hand, wrist, and forearm. There is no reciprocating slide, no recoil spring assembly, and no mechanical delay to absorb that violent energy. Furthermore, you have to contend with the cylinder gap. That small space between the cylinder face and the barrel forcing cone allows high-pressure gas to escape sideways, which creates a massive concussive muzzle blast right in front of your face. This combination causes severe muzzle rise, forces your sights completely off target, and drastically slows down your split times between shots. To make matters worse, you are forced to pull a heavy, double-action trigger for every single follow-up shot, which easily disrupts your sight alignment under stress. Now, look at a modern 10mm semi-automatic platform. When you press the trigger, the expanding gases push the bullet down the barrel while simultaneously driving the slide rearward. Mechanically, that heavy slide and the dual-captured recoil spring assembly act as a highly efficient brake system. They absorb a massive chunk of that peak kinetic energy and spread the recoil impulse out over a significantly longer duration of time. Instead of a sharp, painful snap that drives your hand upward, you feel a heavy, predictable push straight back into the meat of your palm. Because the slide tracks smoothly back and forth, your front sight drops right back into the rear notch almost instantly. Combine that flat tracking with a crisp, short, single-action striker trigger that breaks at 5 pounds, and your split times drop through the floor. On the timer, an average shooter can easily deliver 3 controlled, accurate rounds of 10mm downrange in the exact same time it takes to fight the muzzle flip and heavy trigger pull of a single, well-aimed shot of 357 Magnum. In a defensive engagement, delivering more kinetic energy onto the threat in a shorter window of time is the ultimate metric of performance. Tactical reload speed, under stress. When the adrenaline is dumping into your system and your fine motor skills evaporate, how you feed your weapon becomes a matter of life and death. This is a critical performance metric where the 10mm semi-automatic utterly dominates the 357 Magnum. With a traditional 357 Magnum revolver, a reload is a complex, high-precision mechanical process. Even if you are using modern speed loaders or moon clips, you have to actively manipulate the cylinder release, swings the cylinder out, orient the muzzle completely vertical, slam the ejector rod to clear the spent casings, and then precisely align 6 separate projectiles into 6 separate chambers. Under extreme stress, with sweaty or bloody hands, the risk of a casing getting stuck under the star extractor or dropping a speed loader is incredibly high. If that happens, your gun is out of the fight for an eternity. Now, look at the manual of arms for a modern 10mm semi-automatic. When the slide locks back on an empty chamber, your thumb hits the magazine release, and gravity drops the empty box straight out of the grip. Your support hand strips a fresh, tapered magazine from your pouch and shoves it into a massive flared magwell. The wide opening of the grip acts like a funnel, guiding the ammunition home, even if your alignment is slightly off. You slap the slide stop, the heavy recoil spring drives a fresh round into the chamber, and you are back on target in under 2 seconds. Because a semi-automatic utilizes a single, self-contained fuel source, your reload is faster, more consistent, and requires far less cognitive load under fire. In a defensive encounter, reducing the time your gun is empty is the ultimate insurance policy. Short-barrel ballistics efficiency. There is a dirty little secret about the 357 Magnum that ammunition companies do not want you to know, and it all comes down to barrel length versus powder burn rates. The 357 Magnum was originally engineered to achieve its legendary performance out of 6-inch or 8-inch revolver barrels. When you chop that barrel down to a concealable 2-inch or 3-inch snub-nose platform for daily defensive carry, the ballistics take a massive nosedive. Because Magnum powder is slow burning, a huge percentage of that propellant does not actually burn inside a short barrel. Instead, it exits the muzzle as an unburned cloud, creating a blinding flash and a deafening concussive blast without contributing any velocity to the bullet. On the chronograph, a 357 Magnum fired from a short barrel often drops down to the ballistic performance of a standard 9mm, completely defeating the purpose of carrying a heavy Magnum platform. The 10mm automatic handles short barrels much more efficiently. Because it was designed from day one for semi-automatic pistols, 10mm defensive ammunition utilizes faster burning powders that achieve complete consumption inside a standard 4-inch duty barrel. This means you maintain maximum chamber pressure and extract optimal kinetic energy from a concealable package. When you test them side by side out of carry-size weapons, a high-quality 10mm jacked hollow point will consistently maintain its velocity, ensuring deep penetration and reliable expansion according to strict defensive metrics. The 357 Magnum gives you flash and noise, but the 10mm gives you pure, unadulterated terminal performance. Modern hollow point technology evolution. A common misconception among legacy shooters is that the 357 Magnum possesses a unique, almost mythical hydrostatic shock capability that a semi-automatic round simply cannot match. This line of thinking stems from 1980s testing data when projectile technology was in its infancy. In those days, soft lead or early jacketed hollow points required extreme velocity to expand reliably, which favored the high velocity of the revolver cartridge. Modern engineering has completely flipped that script. Over the last 2 decades, bullet manufacturing has evolved through computer-aided design and bonded core technology. Today, modern premium defensive projectiles for the 10mm, such as the Federal HST or Hornady Critical Duty, are meticulously engineered to expand reliably at a much wider window of velocities. These modern projectiles feature programmed expansion cavities, skive jackets and locked cores that allow them to expand into perfect, sharp petals even when fired from standard semi-automatic barrels. Because of this chemical and mechanical evolution, a modern 10mm hollow point expands to a wider final diameter than an older-style 357 Magnum projectile. When the bullet expands wider, it cuts a clean, massive, permanent wound channel through tissue rather than tearing it unevenly. It achieves this devastating terminal efficiency without needing the dangerous chamber pressures and violent velocity spikes of the older Magnum cartridges. You are getting superior, modern tissue destruction with a modern bullet design, proving that technology beats raw velocity every day of the week. The Modified FBI Gelatin Pro Matrix. When evaluating modern defensive performance, we must look at the gold standard of terminal testing, which is the official FBI ballistic gelatin protocol. This protocol does not just measure a bullet fired into bare gelatin, it forces the projectile to pass through heavy defensive barriers including heavy clothing, drywall, plywood, and sheet metal before entering the testing medium. This is where the physical construction of the 10mm cartridge provides a distinct geometric advantage over the .357 Magnum. To achieve optimum depth according to the protocol, a bullet must maintain its structural integrity and its weight. Because the .357 Magnum uses a smaller diameter bullet, typically weighing 125 to 158 grains, it relies heavily on high velocity to force expansion. However, when that small, fast-moving bullet hits a hard barrier like auto glass or sheet metal, the violent impact often causes the jacket to separate from the core, shattering the bullet into small fragments that fail to penetrate deep enough to reach vital organs. The 10mm operates on an entirely different ballistic principle. It utilizes a wider, heavier projectile, typically weighing 180 to 200 grains. This gives the 10mm a much higher sectional density. When a heavy 180-grain 10mm round impacts a tough intermediate barrier, its sheer physical mass carries it straight through the obstacle without breaking apart. It retains almost 100% of its original weight, allowing it to consistently hit the sweet spot of 14 to 18 inches of penetration in the underlying tissue. According to modern law enforcement metrics, a heavy bullet that stays together through barriers is infinitely more dependable than a light bullet that relies on raw speed. Mechanical ecosystem and accessory architecture. Modern defensive tactics dictate that a firearm is not a standalone tool, it is a complete life-saving system. To maximize your effectiveness in a low-light defensive encounter, your platform must be capable of accepting modern combat accessories. This is a structural metric where the 10mm semi-automatic platform utterly outclasses the traditional .357 Magnum wheel gun. Because a modern 10mm is built on a semi-automatic polymer or metal frame, it natively incorporates an integrated Picatinny accessory rail directly into the dust cover. This structural feature allows you to instantly mount high-output weapon concealment lights like a Surefire X300 or a Streamlight TLR1. Furthermore, modern semi-automatic slides are factory-milled to accept ruggedized miniature electronic red dot sights. Adding a red dot sight allows you to maintain extreme threat focus, vastly increasing your situational awareness and hit probability under stress. Now, look at the structural limitations of a classic .357 Magnum revolver frame. With very few exceptions, traditional revolvers feature a smooth, rounded top strap and a bare underbarrel shroud. They completely lack the real estate required to mount a weapon light or a red dot sight without forcing you to buy highly expensive, bulky aftermarket clamping mounts. These aftermarket mounts ruin the balance of the gun, destroy its holster compatibility, and drastically increase its footprint, making it virtually impossible to carry concealed. In the modern defensive landscape, a gun that cannot accept a light or an optic is a gun that leaves you at a massive tactical disadvantage in the dark. Barra defeat and bore-axis relationship. When analyzing how a projectile behaves during a dynamic defensive engagement, you have to look at the physical relationship between your hand and the center line of the barrel. This mechanical concept is known as the bore axis, and it dictates how efficiently you can control a full-power defensive cartridge. A traditional .357 Magnum revolver suffers from an incredibly high bore axis. Because of the physical design of the cylinder and the internal hammer mechanism, the barrel sits high above the web of your shooting hand. Mechanically, this turns the frame of the revolver into a giant lever. When the cartridge ignites, that high bore axis amplifies the rotational force of the recoil, driving the muzzle violently upward and putting massive strain on your wrist joints. This structural flaw forces you to actively fight the weapon to bring it back down to your line of sight. The 10mm semi-automatic platform solves this physics problem through a low-bore axis design. In weapons like the Glock 20 or the Smith & Wesson M and P10mm, the barrel sits deeply nested down within the slide, positioned fractions of an inch directly above the web of your hand. When you fire a full-power 10mm round, the kinetic force travels in a straight line directly back into your dense forearm bones rather than pivoting upward. This geometric layout reduces muzzle flip to an absolute minimum, allows your hands to naturally track the sights, and ensures that you can dump maximum power into a target with total control. Metallurgical tolerances and stress fatigue. When you choose a weapon platform for serious defensive use, you must look at how the machinery handles physical degradation over thousands of rounds of full-power ammunition. This engineering metric reveals a massive gap in structural longevity between these two platforms. A traditional .357 Magnum revolver is built with a critical mechanical vulnerability: the crane assembly and the cylinder timing teeth. When you fire full-power Magnum cartridges, the intense, violent shock wave slams directly into the frame window. Over time, this repetitive, unmitigated metal-on-metal violence causes a condition known as frame stretching. The cylinder crane begins to warp out of alignment, and the delicate timing hands wear down. When a revolver drops out of perfect timing, the bullet does not enter the forcing cone centered, which causes catastrophic shearing of lead, severe accuracy loss, and eventual mechanical lockup. Fixing a timed-out revolver requires highly specialized gunsmithing that cannot be done in the field. A modern 10mm semi-automatic pistol is engineered from the ground up to thrive on high-pressure cycles. Because the barrel and slide lock together mechanically during the ignition phase and move rearward in unison, the peak physical stress is distributed evenly across heavy steel slide rails and thick polymer receiver blocks. Frame degradation is virtually non-existent because the slide relies on a thick, user-replaceable polymer or flat wire recoil buffer system to take the brunt of the abuse. If a spring wears out after 5,000 rounds, you can swap it out yourself on your kitchen table in 30 seconds without a single tool. In terms of long-term survival logistics and mechanical endurance, the semi-automatic architecture is simply a more durable machine. We have to look at the definitive mathematical equation of terminal defense, the total defensive output metric. Legacy shooters love to point out that a single round of .357 Magnum can deliver 580 foot-pounds of kinetic energy to a target. That is an impressive number for a single shot, but a gunfight is a dynamic multi-adversary event that is rarely solved by one single round. Let us do the real-world combat math. If you take a standard 6-round revolver chambered in .357 Magnum, your maximum energy payload on tap before the gun clicks dry is roughly 3,480 foot-pounds of total kinetic energy. To deploy that energy, you are fighting muzzle flip and clearing empty brass by hand. Now look at a standard 15-round magazine of full-power 10mm automatic ammunition. A proper defensive load, like an Underwood 180-grain jacketed hollow point, leaves the muzzle carrying an incredible 678 foot-pounds of kinetic energy. When you multiply that individual round performance across a full 16-round onboard capacity, your total defensive output metric skyrockets to an astonishing 10,848 foot-pounds of continuous kinetic energy. That is over 3 times the total destructive payload of a revolver, delivered through a flat tracking slide with lightning-fast recovery times. When you look at the raw physics, the mechanical capacity, and the modern bullet design, the 10mm does not just beat the .357 Magnum, it renders it completely obsolete for modern defensive metrics. Make sure you like, subscribe, and drop a comment down below. Stay sharp.